So 510. So now what we're doing is we're trying to find the area not just of nice, pretty little parallelograms or trapezoids or squares or rectangles. We're going to get some weird convoluted shapes. And we're going to have to try to figure out the area of kind of those messed up looking shapes. Good? So the key is what you do is you take this weird looking shape like this one here and you try to break it up into things that you can get the area of. And then find the area of each of those parts, and then kind of combine all those areas together to get the total area at the end. So steps. First, divide the figure up into parts you can find the area of. Such as possibly a triangle and a square. If necessary, find missing lengths. And then finally, find the areas. I'm going to put an emphasis on that S there. Find the areas of those different parts and add them together. Now, sometimes it's possible to take and break things up into something that there's not a good way to come up with the different parts that you need. So for this one, if I really wanted, you could try to do something like this here, but then where do we hit? So that could get kind of ugly. I wouldn't do that personally, but who sees a way we could break that thing up? Go for it. So that's one way we could do it. We could put a line across here. And now this shape down here, what kind of shape is that going to be?
Square.
Ooh, a rectangle. Because square has all the sides have to be the same length, right? So that'd be a rectangle. We could find the area of a rectangle. Could we find the area of this thing up here on top?
Maybe.
What type of shape is that? It's a trapezoid. So we could find the area of a trapezoid, right? Some people, though, prefer to take and break it up a second time into something like this. But you're going to find there's different ways to break it up. Should we try it this way at least?
Sure.
And we could always do it a second way after this if you want to, or maybe just jump ahead. But okay, if we're going to find the area of a rectangle, area of a rectangle is
Area of a rectangle.
base times height or length times width, something like that. And, well, what do we put in for the base? What do we put in for the height? 12 and 10. People agree with that?
Yeah.
It's kind of the base. That bottom part is 12. Height is 10. So we get 120. So the area for this part here is going to be 120. People okay with that number?
Yeah.
Okay. Now the one up above, we said was a trapezoid. Trapezoids are 1/2 height. Then in parentheses, base 1 plus base 2. B1 plus B2. So now if we were to do this, so we have 1/2 of the height. Well, our bases, do you agree base 1 and base 2 are going to be like these here? Because the bases have to be what compared to each other? Looking for a P word. Perfect. Parallel. So these have to be my bases because those are the two parallel sides.
12.
So 30 and 12. Ooh, I like the 12. People are seeing that this side here is the same length as this. So our bases then are going to be 30 and 12. Perfect. I'm going to write those in. So I'll do my parentheses, 30 plus 12. Maybe you did 12 plus 30, you'll get the same answer. How does the height have to be related to the base, or the bases? What direction?
How does the height?
How does the direction of the height always compare to the direction of the base? They have to be...
The same length.
Base and height always have to be perpendicular? So if these are my bases, those in red, my height has to be something like this here with a 90-degree angle. Fair enough? Or maybe it would have made more sense if instead of putting it right there, we could take and say, well, this part here in this kind of light brown is going to be my height. Can I put in a 20 for my height?
Yeah.
No, because 20 is this whole thing. So we have to take off this section here, right?
So would it be 10?
So the height is going to be 10. Now, it looks like I didn't do a very good job drawing this thing to scale, but if you're seeing that 10 is right here, well then this, people are saying, is 10. This section right there is 10. So the whole height of 20, take off the 10, tells me that I have 10 left right there, even though I didn't draw it very well. Does that make sense, people? Okay. So we put in a height of 10. So we have 1/2 times 10, parentheses 30 plus 12.
210.
42 times 5. So that's going to be 210. So this part right here is 210. This part right here is 120. So to get the final answer, I would do
Times them or add.
add them. So 210 plus my 120 gives me 330. Does that make sense to people?
Yeah, it does.
A different way. All right, so if we take and break this thing up, I have this square part here, rectangle rather, is base times height. So the base is
The base is
12.
12 then the height is 20.
Yep. So that gives us 240, if I'm doing that right in my head. So 240. And now if I were to have my triangle, so my triangle here, area of a triangle is 1/2
Times.
base times height. We're going to have to work on those. I'm asking for some of these from memory on the test, right? But since you're showing your work on all your homework ones, you'll know them for sure by then.
What would a base?
Slackers, some of you. Okay. So, ooh, this is going to be a little bit more dicey, isn't it? I mean, this is even more fun. Okay, if you wanted to do base and height, have to be at a 90-degree angle, right? So those two sides are going to be easiest for base and height because they already have this 90-degree angle in there. So we need to figure out the lengths of those two things. Go for it. At least one of them.
Okay, the top one.
Okay.
Top line.
So this part here.
Yeah, that one.
How do we get that thing?
So you're gonna do 12 from the bottom.
Okay.
So you're gonna do like 30 minus 12.
Perfect. So he's saying if you take this 12, we know this side right here is going to be 12. So if the whole thing is 30, if we take this whole length of 30, take off the 12 degree, that gives us what's left?
Yeah.
Oh.
So we'd have 30 minus 12 gives me 18. So we know this red thing there is 18. Now we just need this black length on the side here. Go for it.
You do 20 minus 10.
Perfect. So this whole thing is 20. We want to take off this not drawn to scale 10. So then this one here gives me 20 minus 10. So we know this part here is going to be 10, just like before with that height of our trapezoid. Still good? And now it doesn't really matter which one you call base and height. I kind of rotate this thing to the side in my head. And so I'm going to say base is going to be 10. Height is going to be 18. So we want half of 10 times 18, so 90. So it's going to be 90 total. So I have 90 and I have 240. Any guesses at what we get when we add those two together?
330.
Should be 330, same as before. So the total area would be 330.
Wait, can you go up a little?
Why don't you have Jasmine sing it?
Jasmine knows.
You know that song, Jasmine?
Yeah.
You know 80s
Sing
stuff?
it!
No.
Okay.
Hi, Dad. Let's listen to like the 80s movie all the time.
So this exciting thing here, our last example, who wants to hack it up for us? Go for it, Dorian.
You could put a line. Oh, I know.
Yep, I see what you're doing. Okay, so she's saying she's going to cut it right here.
Oh. Yes.
And, ooh, got another trapezoid. We know you guys love trapezoids. So there equals 1/2 height
Wait, couldn't you
B1 plus B2.
First of all, to make it easier, couldn't you split like come here?
Yeah.
So height. Well, bases have to be two sides that are perpendicular, that are parallel. So we'll call this base 1. We'll call this base 2. And height is going to be perpendicular to those, right?
12.
So height is 12. So 1/2 times 12.
Why is the 12 dotted?
One of my bases is easy, because one base is a length of 8. My other base, ooh, can we say 20?
No, we cannot.
Wait, what did you say?
Oh, 20 minus 6.
Yeah, 20 minus 20 minus 5?
20 minus 6? People like that? You'll notice when you need to add or subtract lengths to get something, they're always going to be in the same direction. This 6 is a horizontal length, so you can combine it with a 20. Never are you going to use this 5 with a 20 to get something that makes any sense. Because 5 is vertical and 20 is horizontal, there's no way to combine those into something decent. So I have a 6 right here. So I could say this other base, B2, is going to be that whole bottom of 20, take away 6. So it's going to be 14. So I have half of 12 times 8 plus 14. Anybody have that thing punched in yet?
22.
So 6 times 22. 132. I love it. So 132 right here.
That's the best number to go.
Now, we're looking for this other side here. I'm going to say it's base times height because it sure looks like a rectangle. The base is 6. The height is...
8.
So we need the length of this black line right here. We need this length right there.
12 minus 5.
Perfect, because this whole height
7.
is 12. So we have this whole side here is going to be 12. We don't want this 5, so I could say 12 minus 5, or 7. So that's going to be a total of 42. So the final answer, we add those two together. So 132 plus 42, 174.
But that's not the old you meant.
Any questions?
How did you know to use the 5 for the teacher?
What I would do is this. I'd look for something that includes that whole side. Well, essentially, they're the only two vertical numbers, so it has to be just those two.
Oh, okay.
But if the whole thing is 12, because this dashed line, dotted line there is 12, I don't want the 5. So if I do the whole thing minus this, that'll give me what's left is that black part.
Okay.
But always look for lengths that are in the same direction, both vertical, both horizontal. Those are the ones you can combine.
Okay.